Hi, Mr. Muskew. So this is basically a video summary of the very first exercise of the year. And before I move on to specific questions in the exercise, I'm going to introduce some of the basic concepts in this program. So basically we have a public class which is known as complex, and class is basically a piece of program source code, and it's also a blueprint of the program. So within the complex class, it's gonna specify the structure of the object's attributes, or what we consider as fields. So in this case, complex is an object which in this instance is ran by the constructor. So when we have so how we define constructor is that it has a name which is the same with the class, and complex, this particular object as we defined, is basically the entity in a running program. And there's also a complex runner which contains a public class and also a main within the class. And notice that it is static in here because it is a main method that does not require an object to exist before it can be called. So that means, with that being said, because an object is not created yet, and that is why we cannot access to the non-static fields within the main. And another example for static method is also the math class that we usually use. So for example, right here. So this is a static method because this is a static method that can be invoked by other classes. And basically in our process of programming, no matter what class that we are setting up, we can still get access to the math class. So now let's start with part A, which requires us to set up a private double field of RE and IM, which represents the real and imaginary parts of the complex number. So now that, as you see, there's a private written in here, which is considered a modifier, and the purpose of that is basically having private means that this particular variable RE can only work within the class, and having private as an encapsulation really helps us to for further error checking, that we don't have to make reference to every single class that we did. We only have to make reference to this particular class because this variable RE and IM would only work in this complex class. And so another example of a modifier is also public, which allows other classes to get access to this particular variable. So for example, in this case, tester. So for part B, we're asked to create a constructor method that would be able to recall a new complex object. So as you can see in this part, because this is a constructor which hold specific values of attributes, and in this case it will be RE and IM, and it will be represented as double D and double E. And another concept I would like to mention is also the scope of these variables. So because double D and double E is within this particular constructor, then we can say it like the scope of double D and double E only works within this constructor. So this is what we're talking about. It's basically the feasible range of a particular variable. And if we go to the complex runner and we actually run the program, as you can see, as we type in this code, then we'll be able to create an object which suits the requirement of the question. And in part C, we are asked to create a constructor method with no parameters that creates a complex object representing the number 0. So one interesting concept that it's worth mentioning is every single time when a class is made, Java actually creates an invisible default constructor that basically looks like what we have done here. So Java has automatically defaulted the values of the complex objects, each of the fields, into 0, And that is why when we go to the runner class and we run the program, we'll see 0 for the first two because of this particular setup. In question D, we are asked to establish the getSet method for all fields, and basically because of the fact that we put private as a modifier to RE and IM, that's why we need a public method to basically allow us to access and also set up the values of these particular variables. And an interesting concept is the get method is under the umbrella of accessor, which allows us to basically access things in Java. And set methods is basically a branch of mutators, which allows us to set up particular values. And in this case will be RE and IM respectively. So here are the sets of getSet method, and if we go back to the complex runner class, and as you see what we did for D, it's basically we set the real part of complex D to 2 and the imaginary part of D into 4, and as we print them out, you will see that we get 2 and 4 in this part. Okay, so next up is creating an instance method that returns the modulus of a complex number. So in this case, the method find modulus, it's actually right here, and using the hypotenuse, which is part of the math class, we're able to find the modulus of a complex number because the formula, it's basically the same, which is the square root a squared plus b squared, and that's also how you find the hypotenuse of a triangle when you're given the two shorter sides of a triangle. Next up, we have question F, which requires us to create a toString method, which allows us to print out a complex number in the form of z equals to a plus bi. So the reason why we use toString is because object is a reference variable. So what complex do in this case is it makes reference to a particular memory location. In other words, it points out the location where the fields of an object are stored. So if we go back to the runner class and we basically rerun the last line, you will see there's a memory location located in here, and this is not particularly what we want because we want it as an object and as numbers that us as readers of the program will understand. And that is why we create such a toString method, so that which accounts for different instances, and we'll be able to print out different complex numbers in terms of string. Okay. So for example, in this case, once we plug in the code and if we print it out, then it will basically show the complete object. So now we move on to the part G, which is creating an equals method that allows us to check if two objects are the same or not. So what we are doing in this instance is basically because there's the part which we take an object and we compare it with the RE and IN within this class. So we will be able to compare if the two objects are equal. So go back to the testers class. If we create two objects that are essentially the same, and then we have the first part, which is the implied object, and the second part, which is the input object, and then we'll be able to check if the two objects are equal to each other. And as you can see, as it prints out true, then that means it verifies in this code and it shows that these two objects are essentially the same because they have the same real parts and the same imaginary parts. And the second last question, part H, requires us to calculate the sum of the complex number by adding the real and imaginary part separately together. So again, we make reference. We basically take an input of. We basically take a complex object as a parameter, and we add RE to the RE of the complex in a parameter, and we're able to find the sum. And in part I, it's a little bit different from part H in the way that we have to return the sum by creating a new object. So the logistics is similar, where we add RE to R2.RE, but then the thing is, as you can see in this part, this particular instance method will return an object, and that's why in return we create a new object which consists of RE and IM. So this is the end of my program, and I hope you enjoy.